All right, problem 3-30 says describe how the graph of y plus 3 equals -2 times the quantity of x plus 1 squared is different from y equals x squared. So we're going to start out here and let's just talk about our graph of y equals x squared first. So if we have y equals x squared, that's our parent graph. And what that'll look like here is we should be pretty good with now knowing that we're going to have a point at the origin. Its growth pattern here, so if we were thinking about it here, like A, the stretch factor would be 1, H would be 0, and K would be 0. Remember, that's how it is for our parent graph. So the locator point is at 0, 0. We're going to go to the right one, and then 1 squared is 1, negative 1 squared is 1. And we got 2 squared is 4, negative 2 squared is 4, got 3 squared is 9, and negative 3 squared is also 9. So it's going to make a nice parabola here. I'm going to do my best to draw it in. And just get the last little piece. Wow, we did it. All right. So that's just our parent graph. And, remember, this equation now is very similar to everything we've been doing. The only difference right now is we have y plus 3. But if we think about subtracting 3 from each side, we can get it into that general form or that vertex form that we're used to seeing in class. That would give us y equals -2 times the quantity of x plus 1 squared. And then we have -3. So our stretch factor here, A, would be -2. Okay, H would be -1, and K would be -3. So our locator point in this one is the point -1, -3, which means this graph here, how is it different? Well, this one is going to be, first of all, vertically stretched, right? Because we have a stretch factor of 2. So we're going to say this is going to be vertically stretched by a factor of 2. This one's also going to open down, right? Because this is a negative. So we're going to open down. And then because we've moved our locator point to -1, -3, it's going to go left 1 and down 3. I'm going to shift it left 1. And we'll just put that up here too, and down 3. So let's see what it looks like here. We're going to go, first of all, to our locator point. We're going to go left 1, and we're going to go down 1, 2, 3. So here's our new vertex. Remember, it no longer opens up, it now opens down. And because our stretch factor is -2, it's going to go down twice as fast as it normally would. Usually we go left 1 and we go down 1, but now we're going to go left 1 and we're going to go down 2. So it's going down twice as far. If we went right 1, we go down 2. And if we went left 2, normally we would go down 4, but now we're going to go down twice as many. So we're going to go down 1, 2, 3, 4, 5, 6, 7. It actually jumps off, but we'll just put our point down there. And we'll reflect it over and get that one here. So then we'll just kind of sketch it in. Oh, it's really hard to draw them on this program. There we go. Not perfect, but usually isn't anyway. We have here So how's it different? It's vertically stretched by a factor of 2, it's opening downward, and it's shifted left 1 and down 3. That's where our new parabola is coming from. So that's the difference between our y plus 3 equals negative 2 times the quantity of x plus 1 squared and our graph of y equals x squared, the parent graph. If you have questions on this, you need to make sure you get help. We've been doing it for a while, so if you're still not understanding, you need to reach out and get some support from someone. Hopefully this helped clear up some things for anybody who had some issues. Thanks for watching.